Now let us see how to find out the oxidation number. Before balancing the chemical reaction by this oxidation number method, you have to know how to find out the oxidation numbers. Then only you can apply this method very easily. Say for example, let me write KMnO4. See, this is potassium permanganate. Say the manganese, no? The manganese oxidation number. Suppose you are going to find out. Then how to do this thing? Say for potassium, no, it is belonging to what? Alkali metal. So it is oxidation number is +1. So for potassium, I am writing the oxidation number, say +1. Yes, sir. Then you have manganese. This you don't know the oxidation number, so I am keeping this as X. Okay. Then oxygen, you know, oxidation number of oxygen. Oxidation number of oxygen is -2. So I am writing -2. Okay. Now let us do the process. See, this is potassium. It is +1. Potassium, it is +1. And plus this is the total, no, this is a molecule, and the oxidation number of all the elements present over here, no, the total oxidation number of all these elements, no, it should be 0. That is, it should be neutral. So we are adding all the oxidation numbers of all these elements. So plus the X. This X is what? Manganese. So I am keeping this as manganese itself. And see, for this is -2. Oxidation number of oxygen is -2. And how many oxygen? That is 4 oxygen, which will be equal to 0. Okay. Then what is the equation? +1 plus manganese. Yes, sir, manganese, and -2 into 4, it is -8, which will be equal to 0. So here it is +1 and it is -8. So the total is nothing but what? -7. No? -7. And what is that? Manganese. Manganese, that is -7, will be equal to 0. And you need the oxidation number of manganese, so which will be equal to +7. Okay. So now what is the oxidation number of manganese, which is +7. So now I'm writing this over here. See, +7. Manganese is +7, and for 4 oxygen it is -8. See, -8. And for potassium it is +1. So now see the total. It is -8 and +8, and it is -8, and total will be equal to 0. So this molecule, no, which is neutral in nature. Is it okay? So this is how we have to find out the oxidation number. So one more thing, let us see. Potassium dichromate, another compound. Let me write. That is potassium dichromate, K2Cr2O7. Okay. Now we have to find the oxidation number of chromium, because you know the oxidation number of potassium, that is alkali metal, and oxygen also you know. So this you keep it. This you have to find it out. Okay. So now here, as we done over here, so potassium it is 2. So for 1 potassium it is +1, and this you keep it as how much? X, and oxygen it is -2. So now you do the thing. So for 2 potassium it is +2. Yeah. So here plus, and how many chromium? 2 chromium. Yes, sir. So I am writing 2 chromium. All right. And oxygen -2, and how many oxygen? 7 oxygen. So it is 7 will be equal to 0. So here +2 chromium. Yeah. It is -14 will be equal to 0. So +2, here -14. So 2 chromium. So -12 will be equal to 0. Yeah. So 2 chromium will be equal to +12. And chromium will be equal to +12 by 2, which will be equal to what? +6. Yeah. So now you substitute the oxidation number over here. So potassium +2, we are writing over here +2, and chromium, 2 chromium. For 1 chromium it is plus 6, so for 2 chromium it is plus 12. Yeah, and for 7 oxygen it is minus 14, minus 14. Now you see the total, it is plus 14 and minus 14, which will be equal to 0. Yeah, so this is how you have to find out the oxidation number. Okay, so to find out the oxidation number, as I told you, you have to know all these rules, no? For natural state or in the elementary state, oxidation number of all the elements are 0, and alkali metals it is plus 1, and alkaline earth metals there it is plus 2. For hydrogen it is plus 1, and in the metal hydrides it is minus 1. Oxidation number of oxygen is minus 2, and mainly in peroxide it is minus 1. And oxidation number of fluorine is minus 1. Always it is minus 1. Like this you should know the rules for writing the oxidation number. Is it clear? Okay.